Alright, now let's look at some examples of finding and simplifying derivatives for each function using the product and quotient rules. So the first one, p of x is equal to x squared minus 4x plus 3 times x minus 2. So remember, the product rule tells us that if I have two functions and call them f of x and g of x, then what we need, so in this case, I'm going to call x squared minus 4x plus 3 my f of x, and x minus 2 my g of x. Then I need to find, first, I need f prime of x and g prime of x to be able to actually find the derivative of p of x. So in this case, f of x, I said, was x squared minus 4x plus 3. So f prime of x then is going to be 2x minus 4. G of x was x minus 2, so g prime of x then is 1. So now to find p prime of x, if p of x was f times g, we know p prime of x then is going to be f of x, so first times derivative of the second, so times g prime of x, plus the second g of x times the derivative of the first, so times f prime of x. And now we're just substituting in everything. So f of x was x squared minus 4x plus 3. G prime of x was 1. And then plus, so now g of x, so x minus 2 times the derivative of the first, so times 2x minus 4. And now we're just simplifying and cleaning up. So x squared minus 4x plus 3 times 1 is x squared minus 4x plus 3. X minus 2 times 2x minus 4 is 2x squared minus 4x minus another 4x plus 8 if you full it out. And in this case, I don't need parentheses. I could put parentheses around each term, but because we're adding in between them, it's okay if you don't. And so then cleaning it up, so that's x squared minus 4x plus 3 for the first term, plus, and then the second piece, 2x squared minus 8x plus 8. And then now combining all our like terms, we end up with p prime of x is equal to 3x squared minus 4x minus 8x, so minus 12x, plus 3 plus 8, so plus 11. And we're done. Okay, so let's look at this one. So f of x equals x squared minus 3x times x squared plus x minus 1. So to differentiate this using the product rule, so f prime of x is equal to our first function. So in this case, our first function is x squared minus 3x. So first times derivative of the second. So our second function we know is the x squared plus x minus 1. So the derivative of that is 2x plus 1. Plus now the second function stays the same, so x squared plus x minus 1 times the derivative of the first, so times 2x minus 3. So let's simplify this now. So multiplying out x squared minus 3x times 2x plus 1, you get 2x cubed plus x squared minus 6x squared minus 3x. And then plus the product of x squared plus x minus 1 and 2x minus 3 is 2x cubed plus 2x squared minus 2x minus 3x squared minus 3x plus 3 when you multiply that all out. And now that since it's addition, we can drop these parentheses and start cleaning up, combining all our like terms, and you should get 4x cubed minus 6x squared minus 8x plus 3 for the final answer for your derivative. Alright, how about this one? So h of x is equal to x over x minus 5. So like before, let's start out, since this is the first one we're doing with the quotient rule. Let's call this numerator x equal to f of x. Call my denominator equal to g of x. So we know we're going to need f prime of x. So the derivative of x is 1. And the derivative of x minus 5, so g prime of x, is going to be 1 also. Note, I don't care if you do this out to the side like this, just make sure that if you do, you define your functions. Because if I didn't define it and say, okay, this is the numerator's x, f of x, and the denominator's g of x, then if you're writing over here on the side, f prime of x, g prime of x, I'm not going to know what you're talking about. And chances are when you go back and look, you're not going to know what you talk about. Plus, not to mention, you'll lose points. But if you define it, I have no issues with you doing that. Now, you wouldn't, for example, on this last one, I wouldn't want to call this first one f of x. Why not? That's right, because our function itself is already called f of x. Now, I could call this one something else. If I wanted to call this g of x, that h of x, and then do the same thing, find g prime and h prime, and then just substitute into the product rule. You can do that, and that's fine. Just make sure you're not calling it the same thing as your function. So now let's differentiate this. So by the product rule, so h prime of x is going to equal to the bottom times the derivative of the top, so g of x times f prime of x, minus the top times the derivative of the bottom, so minus f of x, g prime of x, all over g of x quantity squared. So substituting in now everything we know, so g of x we know is x minus 5. F prime of x is 1. So x minus 5 times 1 minus high d low. So easy way to remember this, low d high minus high d low all over low squared. That's an easy way to remember the quotient rule. So low times the derivative, bottom times derivative of the top, minus top times derivative of the bottom, all over bottom squared. So here that's x minus 5 times 1, minus f of x is x, g prime of x is 1, all over g of x squared, so x minus 5 quantity squared. Cleaning it up a little bit, so this is x minus 5 times 1 is just x minus 5 minus x all over x minus 5 squared, and x minus x cancels, so we're left with negative 5 over x minus 5 squared, and that's as much as we can do. You could multiply this back out, but we're normally not going to want to do that because of looking forward to what we're going to do next. We're going to be setting this denominator equal to 0 to find values where this function is undefined. So if you think about finding domain of this function, right, then it's going to be easier to do that in this already factored form, so where it's written as x minus 5 squared, than if you were to multiply that out. All right, so let's look at this one. So f of t is equal to t plus 6 over t squared minus 8. Now again, you could define these functions. If you did, you'd want to use something like g and h or n and d or something, so that you're not calling it f, one of these pieces f, just because of the fact that our function itself is already called f of t. And then if you did it, make sure you matched your variables. So for example, I could call the numerator g of t and the denominator h of t if I wanted to, and then find their derivatives. But let's just go ahead and do this using the product rule. So f prime of t is equal to low d high, so bottom times derivative of the top, so the bottom is t squared minus 8. Derivative of the top, so derivative of t plus 6 is just 1. Minus the top, so minus t plus 6. Times the derivative of the bottom, so times 2x. All over the bottom squared, so t squared minus 8 quantity squared. Now, I do not recommend, again, multiplying this out, fulling it out, because it's going to make your life more difficult when we get into the next chapter. Alright, so simplifying this now, so t squared minus 8 times 1 is just t squared minus 8, minus, and sorry, this should be 2t up here, not 2x. So minus 2t times t, so 2t squared plus 12t. And remember, you're subtracting that whole thing, so it has to be in parentheses. All over t squared minus 8 quantity squared. So that's t squared minus 8 minus 2t squared minus 12t, distributing that negative through now, over t squared minus 8 quantity squared. And then just cleaning that up, we end up with negative t squared minus 12t minus 8 over t squared minus 8 squared. You could factor a negative 1 out of this if you wanted to and rewrite it, but you don't have to. It's not really going to help us in any way right now to do that, and so I wouldn't do it. Alright, so let's look at the next one. A little bit more complicated just because we have a quadratic involved in the numerator instead of a linear equation. So if we start doing this just directly by the quotient rule, so f prime of x then, low d high, so x plus 4 is our low, times the derivative of the numerator, so times 2x minus 1, minus high d low, so minus this quadratic x squared minus x minus 20, times the derivative of the bottom, so times 1, all over x plus 4 squared. Cleaning it up, multiply it out, right? So x plus 4 times 2x minus 1, you get 2x squared minus x plus 8x minus 4, all minus x squared minus x minus 20, still all over x plus 4 squared. And so then distributing through the negative, combining like terms, we end up with x squared plus 8x plus 16 over x plus 4 squared. And so I ask you this, are we done at this point? We've written other ones similar to this like this in the past, but are we done? So hopefully if you're looking at this, you should see that x squared plus 8x plus 16 can factor fairly easily and is actually one of your special perfect square trinomials, right? So x squared plus 8x plus 16 is x plus 4 squared, right? So we've got x plus 4 squared over x plus 4 squared. And then we can simplify that, right? What is anything divided by itself? It's 1. So the derivative of this, f prime of x, is 1. All right, let's throw a little trig in there. So y is equal to x to the 4th over cosine x. So what do I want to call this derivative now? Do I want to say f prime of x, or do I want to say y prime? That's right, I want to say y prime. So y prime is equal to the denominator, cosine x, times the derivative of the numerator, so 4x cubed, minus the numerator, x to the 4th, times the derivative of the denominator, derivative of cosine x is negative sine x, all over the denominator squared, so cosine squared x. Let's clean it up a little bit, so that gives me 4x cubed cosine x plus x to the 4th sine x all over cosine squared x. Are we done? No, we can keep on simplifying, right? So if we split this up, we can factor at the very minimum, we can factor out a x cubed over cosine squared x, right? And that leaves us with 4 cosine x plus x sine x, right? Now, would we want to do this, though? Does that really make it any cleaner? Probably not, right? So I probably wouldn't simplify it this way. What I would start out doing is I would just break this up into two separate rational pieces, right? So undo the fractional addition if you think of it that way. So make this 4x cubed cosine x over cosine squared x plus x to the fourth sine x over cosine squared x. And now hopefully you're starting to see some stuff that you can simplify, right? What's cosine x over cosine squared x? So that's 4x cubed over cosine x, right? Plus a sine over cosine x, we know is a tangent, right? So plus x to the fourth tangent x over cosine x, right? And now, what can we do? So now is when I would go ahead, put this back together, pull out what I can pull out, right? So what do we know? So we know we can pull out an x cubed, and we can pull out 1 over cosine x. But what is 1 over cosine x? That's right. It's secant x, right? So that we end up with x cubed secant x times what's left over. So we have a 4 left over, and we have x tangent x left over. And that's as far as you can simplify it. All right, let's look at one more using the quotient rule. So f of x is equal to 8x plus 1 over e to the x. So taking the derivative of this, so f prime of x is equal to low d high, so denominator e to the x. Derivative of the numerator, so derivative of 8x plus 1 is 8. Minus the high, so minus the numerator, 8x plus 1. Times the derivative of the denominator. What's the derivative of e to the x? Yes, it's e to the x. It's the only function that it says own derivative, right? Excluding f of x equals 0. All right, over e to the x squared, right? And remember, if e to the x squared, using your exponent properties, you can rewrite this as e to the 2x. So cleaning this up now. Right away, we can factor an e to the x out, right? So that leaves us with 8 minus 8x minus 1 all over e to the 2x. So then 8 minus 1 is 7, so we're left, and then e to the x over e to the 2x just leaves us with 7 minus 8x over e to the x. And even though I'm not writing out every single step explicitly, I encourage you, when you're doing these, you need to write out every single step. So you should be going through as you're working these examples and filling in the steps that I'm not writing out to make sure that you're comfortable doing that algebra, because you're going to have to do it on the test.